Hi, my name is Muhammad Agudi Musafuddin. My matrix number is AN2054.
Hi, I'm Matthew Brandon. My matrix number is CN200117.
So, we are from group 12. Okay, today I would like to explain about our experiment. So, our experiment is we need to conduct the centrifugal force. So, I would like to explain the objective for this experiment. So, the objective of this experiment are to illustrate how the centrifugal mechanism works and also to prove the following centrifugal force concept, like the theoretical equation which is F equal to mR. So I would like to intro. I would like to explain the equipment that we need for this experiment. So we need to have this machine which is the machine for to calculate the centrifugal force, and also we need to have this kind of load. So this load we have one different weight, which is we have 100 gram, 40 gram, 20 gram, 10 gram, 60 gram, and 50 gram. So with using this load, we can calculate the centrifugal force and differentiate what the difference between the load. Thank you. So for this experiment, we have two tables. The first experiment we run with the same mass. For example, like 10 gram mass with variance of speed. For next table, we run the experiment using the same speed but different mass, like 10 grams, 20 grams, 30, and many more. Push on the plug. The first thing is, before you run the experiment, you need to make sure that the force here is 0.00. So this is not 0.00. So you need to press and hold to 0 force. You press. See? It's turned to 0.00. So the first experiment, we need to open this. Can you help me, someone? So first we need to arrange the load. This is 40, this is 20, 20. Put here. Make sure the pins correct, fit very well. Okay. And then we need to run until the speed is 30 radian per second. Press and turn slowly. It's okay, it's plus minus. So the force negative here, see negative here is about the rotations, clockwise or anti-clockwise. After we get the speed 30 radian, we need to read the reading this one on the computer. So we need to pick up and collect the data for the force. Here state 3.65. So we take this value and put it into our table, and then we can repeat with the different load. Okay, for the next experiment, we need to make sure that the mass is fixed. For example, like 40 grams, then we need to change the velocity. So we use like 5 radian, 10, 15, 20, 25 So here for example, we use 40 load and we need to stick this load but with using the different value of velocity. So we get 5 and the centrifugal force is 0.13 Newton. So we need to record all the data for the barrel speed and put it into our table as our result. And then repeat the next step with difference velocity. And after that, we finish this experiment. Don't forget to switch off the power.
Hi, this is the result of the experiment that we have collect. So here is the table 1. This is the data experiment for the fixed mass and radius, but we change the speed. And table 2 we put the speed is 30 radius and the radius for the table 2 is 0.1. And for the table 3, as we can see here, we fix the speed and mass, but we change the radius. As you can see here, this is all the data for the experiment that we have collected. And on my side, we have the graph. This is the force against mass. As we can see here, when the force increase, the mass also increase with it.
For this experiment, we conducted 3 experiments, which is fixed mass and radius, but with varied speed, fixed speed and radius, but with varied mass, and fixed speed and mass with varied radius. The data for the experiment were recorded in a table for result, and graph were plotted for each experiment. To prove the theory, based on the centrifugal force experiment that we conducted, we can observe how the centrifugal mechanism works. For this experiment, a hypothetical force called centrifugal force, which is unique to particles traveling in a circle, has the same strength and dimension as the force, keeping the particle on its path, but it acts in the opposite direction. The apparatus for rotatingly measuring centrifugal force is mounted on a big pulley wheel.
Okay, so we can discuss about the theoretical force, and the actual force is almost the same as we got, because as an example, with the velocity of 30 radius, we got the 8.83 Newton of actual force. With the theoretical force, that is 9 Newton. From the graph, we can observe that of the speed, force versus speed, we can observe that the centrifugal force is directly proportional to the speed. This proves that our objective is to the speed of and centrifugal force are proportional. On the table 2, the speed and radius are fixed but various mass. The speed that we use is 30 radius. So on the using the table 2, that show that centrifugal force is directly proportional to the mass in the force against mass graph. On the table 3, the mass and speed is fixed but various radius. Based on the graph that we have done, we can say that centrifugal force that we got is directly proportional to the radius in the force against radius graph. The evidence from the outcome is that the linear relationship between centrifugal force, mass and angular velocity and radius, since the centrifugal force result from inertia, which is the tendency of the masses to continue moving in straight line, the centrifugal force will change in the mass, speed or radius change. According, the greater the speed, mass or location of the mass, the greater the centrifugal force that we will got. So, in conclusion, this experiment is very challenging for us. It is because that it is quite impossible to get the exact angular velocity that we got. But nevertheless, we must correct our mistake. For example, we must check the reading carefully because we must all take the 2 decimal places. So we must always check the apparatus that we use and correct our mistake by far. Thank you.